Alright, so today we're going to be talking about section 8.4, synthetic division. This is kind of a neat little trick that can help us quickly divide polynomials by certain binomials. Might look a little strange at first, but it actually does work. Once you get used to it, it goes really quickly. Alright, let's get started. So this is a special case. We can really only do this when we're dividing a polynomial by a binomial of the form x minus c. So that's a linear binomial. Coefficient of x is 1, and I'm subtracting some value from it. And we can use this process called synthetic division, and we do the process very quickly. And really it just makes us look at the coefficients in our dividend polynomial. That's really where we focus. And so to start, what I'm going to do is I look at my problem. So make sure this is going to be a candidate for synthetic division. I have a polynomial. I'm dividing by x plus 4. So that doesn't look quite like x minus c, but I remember, like I've done with lots of scenarios such as parabolas and circles and those equations, I know that if I have a plus and it's supposed to be in the form of x minus something, it just means that I'm subtracting a negative. So my value of c here is negative 4. That's really what I'm looking at in this particular case. My c is negative 4. Then it would have that form of x minus negative 4, and then we know we're good. So to start off, I'm going to take that value of c, and I'm going to put it in a little box up here. This is just an organizational way to keep track of it. Now I'm going to take the coefficients from my dividend polynomial and write them out in order next to this negative 4. So I'm going to go 2, 9, it's just an x, so that's 1, and negative 12. I'm going to leave a little space here and put a line underneath. Now again, this is where this looks strange and we maybe wonder where it's coming from. We can get into that during class, but for now, I'm just going to try to learn the process and see what we can do with it. So I'm going to take this 2, and I'm going to actually bring it down and just write the 2 again. So whatever my original first coefficient is of 2, in this case, I'm going to put it there, and then I actually just bring it down. Now I take the negative 4, and I multiply it by 2 and put that answer up here. So that's going to be negative 8. Alright, so again, that's negative 4 times 2 is negative 8. Now I just add down. 9 plus negative 8 is 1. Alright. I repeat this process once again using negative 4 multiplied by the 1 and putting that answer here. So negative 4 times 1 is negative 4. And once again, I add down. 1 plus negative 4 is negative 3. And last time, negative 4 times negative 3, put that answer here. That's a positive 12, which negative 12 plus 12, once again I'm adding down, actually cancels out and just leaves 0. Now, since that's the last piece, I'm actually going to use a dotted line and box that off at the end as well. Alright, what does this mean? Well, amazingly enough, this 2, 1, and negative 3 are going to serve as coefficients of my final answer. And really what I have to do is I just have to reduce the degree of my original polynomial by 1, which makes sense because I'm dividing an x cubed by an x, which is going to reduce it to an x squared. So I'm going to take the 2, and that becomes a 2x squared. The 1 becomes a plus 1x, or just x. And the minus 3 is just that number of negative 3. The 0 at the end, that's my remainder. That means that this division works out perfectly, meaning that x plus 4 is actually a factor of 2x cubed plus 9x squared plus x minus 12. If that's the case, it divides evenly, and this is my resulting answer. 2x squared plus x minus 3 is my final answer. That's it. That's all it takes. Alright, let's get some more practice now. So we're going to complete this process again. In this case, we're going to have a remainder other than 0, but we just write it over our original divisor, just like we did with long division. So we're going to use synthetic division to complete these. Start off by identifying our c, what's being subtracted from x. In the first case, subtracting 1. Don't make it a negative 1. Remember, it's the opposite of what you see. Then we write our coefficients. So it's a 2x cubed, negative 3x squared, a 4x, and a 5. And we know we bring down the 2 at first. Multiply 1 by 2, put it here, that's 2. Add down, negative 3 plus 2 is negative 1. Multiply that by 1, obviously it's not going to change. Put that up here is negative 1. Add down is 3. 1 times 3 is 3. And 5 plus 3 is 8. Again, I'm going to block that off. And again, I've taken an x cubed and divided by an x. So I'm going to be reducing my polynomial so it's of degree 2. Taking each of these here as my coefficients. That means my answer is going to be 2x squared minus x plus 3. And since my remainder is 8, I do plus 8 over my original divisor, which is x minus 1. And that's it. See how quick that is compared to long division? This is pretty awesome. It's a really quick, easy way to do it. So go ahead, try it with the next one, then pause the video, come back, and see how you did. All right, how'd it go? And that's what we end up with. Remember, once you use synthetic division here, to go back and use the correct variable, it should be 2t squared plus 7t minus 3 plus negative 19 over t minus 3. Certainly, you could replace this here with minus and make your numerator 19. Either way is acceptable, but there you go. Something that's really, really important with synthetic division is that you have to use placeholder zeros for anything that's missing. With long division, because we're using the variables, we could catch those mistakes more. Not likely to happen with synthetic division unless we use the zeros properly. So if I look at my first example, I have 2y cubed minus 9y plus 3. I've jumped right from my y cubed to my y term. So I'm going to have to account for that when I'm doing my synthetic division setup. For this one, I'll set it up. I'm going to start with my c, which what's being subtracted from y here must be a negative 2. And when I go to put in my coefficients, I have the 2 for the y squared. I have a 0 for the 2 for the y cubed, 0 for the y squared, negative 9 for the y, and a 3 for the constant. Then I go through the process as normal. Bring down the 2, multiply by the negative 2, put my answer up there, that's negative 4. Add down is negative 4. Negative 2 times negative 4 is 8. Add down is negative 1. Multiply again, negative 2 times negative 1 is positive 2. Add down is 5. And we get that there. So now, again, it was a y cubed, so I'm going to go down one level, and this is, you kind of go backwards here and think, oh, this is constant, this is linear, this is quadratic, and we're just going to use the correct variable, so I'm going to say that that's 2y squared minus 4y minus 1 plus 5 over y plus 2. And that's what we should end up with. So go ahead, why don't you give it a shot for the next one. Keep in mind you're starting at z to the 7th, so there could be a lot of placeholders here. But once again, pause the video, try it out, and then come back and see how you did. All right, let's check. Whew, okay, so there we are. Bet you didn't think it was going to work out nicely, but as a matter of fact, z plus 2 is a factor of z to the 7th plus 128. So after having 1, 2, 3, 4, 5, 6 placeholder zeros in between, we end up getting this long polynomial, z to the 6th minus 2z to the 5th plus 4z to the 4th minus 8z cubed plus 16z squared minus 32z plus 64. So there you go. It works. pretty incredible. So just a couple of things to wrap up this lesson, a couple of special cases. We can actually use synthetic division even with imaginary numbers. We just follow the same process and combine like terms as we can. So let's take a look at what we have here. I have x cubed plus 3x squared minus 2x plus 3i. So 3i is serving as my constant here because I is just representing the square root of -1. I'm dividing that by x minus I. So when I set up my synthetic division, my c is I here. That's what I'm subtracting from x. I'm going to write in my coefficients. I'm going to leave myself a little bit of space here now. I get a 1x cubed, 3x squared, -2x, and then 3i. So I'm going to start by bringing down the 1. And I do I times 1, which is I. Now, that's going to be 3 plus I. I can't combine those as like terms, so I'm just going to write it as a binomial, 3 plus I. Now I'm going to multiply I by these two things, but when I do that, I have to distribute. So I'm going to have I times 3 is 3I, but I times I is I squared. Now, I squared, remember, is -1. So I have -1 plus 3i. When I add down, I'm going to combine like terms. -2 plus -1 plus 3i. I can combine the -2 and -1 and get -3 plus 3i. And now I multiply once again I times both of these. And I times -3 is -3i. I times 3i is 3i squared. Once again, I squared is -1, so that becomes a -3 and a -3i. So I'm going to put that together. I got -3 minus 3i. And when I add down, the 3i and -3i cancel, leaving just -3. So I'm going to rewrite my answer, and I'm actually just going to have some coefficients that involve I. Start with an x cubed down to an x, divided by an x and down to an x squared. So I'm going to have a 1x squared for my answer here. My next coefficient is 3 plus I. So I'm going to say plus 3 plus I x. And then I'm going to attach the end as my constant, and it's just actually a constant in two parts. -3 plus 3i. And then at the very end, I just need to include my remainder. So I'm going to say plus -3 over x minus I. And there we are. So we won't be doing a lot with this in class, but just wanted you to see that it actually does work. So speaking of things we won't be doing a ton of in class, this is just another example where it's a little bit more complicated, but we can actually still get away with using synthetic division. And so what we're dividing by here is a binomial with a coefficient other than 1 on our x here. See, I'm dividing by 4x minus 7. I can't just put a -7 into my little box for c. So what I have to do is I can think about this as saying, well, this is the same as 8x cubed plus 2x squared minus 49, and I'm dividing it by 4x minus 7. Well, what I'm going to do is I'm just going to take this and take out a 1/4, is really what I'm going to do here. And what that does is it keeps my numerator the same. 8x cubed plus 2x squared minus 49 over. Now when I take out the 4 from my denominator, that leaves me with x minus, it's not going to work out nicely, but I just write it as 7/4. The reason I've done that is now what I've set up is in my parentheses, I've set up something that I can use synthetic division for. My c is now 7/4. This will allow me to do the synthetic division, and then at the end I'm going to multiply my final answer by 1/4, basically dividing by 4. Essentially what I'm doing here is I'm multiplying by 4 and then dividing by 4 after doing the synthetic division. it keeps it the same, it just makes it easier to do. So I'm going to set up the synthetic division using the problem in the parentheses. My value for C is 7/4. And then my coefficients are 8 for the x cubed, 2 for the x squared. I don't have an x, so I need to use a placeholder of 0. And then I have negative 49. So let's go ahead through here, bring down the 8. 8 times 7/4, okay, not so bad, cancels a little bit. 7/4 times 8, 4 and 8 cancel to make 2, that gives me 14. 2 plus 14 is 16. Then I can do 16 times 7/4. Once again, the 16 will cancel with the 4 to make 4 times 7 is 28. Bring down, add those together, get 28. And then do 7/4 times 28. The 4 and 28 cancel, leaving 7. Times 7 is, oh, actually, that works out nicely. That's 49, which means my remainder is 0. So that kind of translates into 8x squared plus 16x plus 28. But that's what is in parentheses. I then have that 1/4 that's on the outside. So for a final answer, I have to do 1/4 times each of those, and that brings me to 2x squared plus 4x plus 7. And so that's a little trick, little special case that we can use there. But that's a good way to do synthetic division. So hope this makes sense, and there we go.